Hello! In this lecture, we're going to talk about Chapter 13, Analyzing Relationships for Categorical Data. This is Chapter 13 within your textbook, and we'll be talking about some more advanced ways of understanding relationships between variables. So to start off our introduction here, this chapter covers a number of things, including bivariate analysis, multivariate analysis, test of statistical hypothesis, nominal and ordinal level measures, and interval and ratio measures. So just to give you a little bit of a background on what these words mean, because there are many syllable words that mean very simple things we've been talking about all semester. Bivariate analysis is an analysis that you conduct when you're looking at two variables. That is what you all are doing within your papers. So you're looking at an X and a Y, or independent variable and a dependent variable. A multivariate analysis takes it a step further, and in this type of analysis, you're looking at one dependent variable, but you're looking at multiple independent variables. So instead of having one X and one Y, you will have one Y and multiple X's, which is what you see most commonly in scholarly articles. Test of statistical hypothesis. This is where we're going to talk about the different tests that you can use in statistical software to determine whether or not to accept or reject a hypothesis. Nominal and ordinal interval and ratio measures. We're talking again about the level of measurement that you're going to use, that you have for your variables, so that you'll be able to pick the correct statistical test. So we need to start there, talking there. It should be a refresher for us to discuss this because it's something that we've covered in detail. But in order to know which test you're going to use, you have to know your levels of measurements. As I've stated, we have 4 levels of measurement: nominal, ordinal, ratio, and interval. Just to refresh, nominal, that is a name category with no real numeric value associated with it, like gender or a racial group. Ordinal, these are ordered rankings where the number doesn't have a strict value from category to category, the same distance from category to category, but there is a rank attached to it. Ratio, this is where you have strict numerical values, but there is no there is a meaningful zero. And interval data would be the data where you have strict numerical values, but there isn't a meaningful zero. And these are all things that we've talked about thus far and that we've discussed. But in more simple terms, the focus of this chapter is on categorical data. Now, we haven't used that term a lot, but we've been talking about categorical data throughout the semester. And categorical data is simply the opposite of scale data. We know that scale data, as I mentioned, those are the ratio and the interval variables. Those are the raw numbers that are tangible. They fit the category of being discrete or continuous values. But categorical data would be the nominal and ordinal section of it, where we're talking about the name labels and we're talking about the rank orders. So what we're talking about within this chapter is about using nominal and ordinal data and how to determine whether or not a relationship exists for variables using that sort of data. But in general, what we're doing is examining how two things are related to each other. We are looking at how 2 or more variables are related to each other and finding the right test to use in order to make that determination. In our previous chapters, we have been talking about recently about one variable. Usually we were talking about Y because you saw Y bar or X and X bar. We always talked about those things individually in the last chapters because we were just talking about a single variable. Well, moving into this chapter, we're putting all of the pieces together, and in chapter 14, putting all the pieces together so that we can talk about your 2 variables as a team, as a couple, instead of talking about them individually and what that category of data mean. We're going to talk about what those 2 categories of data mean together. So first, we want to start with talking about the way that values relate to each other. Within this section, we're talking about how these measures for each of the variables form a relationship, and there's also a strength of that relationship that we have to assess. So we have our variables and we have to figure out what measure and how to measure them. Do you have a variable that is just categories? Do you have a variable that's rank order, that is numbers without a meaning for zero, that is numbers with a meaning for zero? We get that scale of measurement first, and then we're able to discuss the form of that relationship using those statistical tests. And once we're able to discuss the form of that relationship, we're able to move forward and to start talking about the strength of that relationship. And we'll cover that within this lecture. And within that strength of that relationship, we can look at them using numerical summaries of the relationship that we see in tables and figures. So we'll talk about all of that. So this is a chart that presents you with the different levels of measurement and tells you which test that you need to use when you're dealing with different sorts of data. I find this chart to be very useful, especially for students. If you know what type of data you have, then you can just look over and decide which test you need to use based on your data. An example we can pull from here. If you know you have categorical data as far as the dependent variable is concerned and categorical data as far as the independent variable is concerned. Let's say you're interested in gender and party ID. You know that those two things are both categorical data. So the source of tests that you use are limited to those that are acceptable for categorical data. And if you look over on the procedure on the side, you see that you'll end up with cross classification tables and measures of association. And we'll talk about those. They typically look like chi-squares and contingency tables, cross tabulations, that type of stuff. But yes, this table provides you with like a quick little shortcut to know which type of test or procedure you'll need to do in order to figure out whether or not a relationship exists for your variables. So there are a couple of different types of relationships that you can see in data, specifically categorical data. The first is a general association. And your book defines a general association as knowing the value of one variable and how that variable helps you to predict the value of another one. A general association means exactly what it sounds like. It means that these two variables, we know that they are connected in some way and that they basically go together. We know we can't specify the direction of that relationship, the strength of that relationship, but a general association means that we know that these two things are related to each other and that they go together. But if we want to take it a step further and have a deeper understanding of the relationship between variables, we start to think about the monotonic correlation between two variables. And that is just a fancy way to say the types of correlations that are possible. And there are two major categories. You have a positive correlation and then you have a negative correlation. A positive correlation means that high values on one value are high values on one variable are associated with high values on another variable. But you have a negative association that says high values on one variable means that it is associated with low values on another variable. So positive is both high and high. Negative is high and low. It's positive because they are both going in the same direction. Negative means that they're going in opposite directions. So it's high and high versus high and low. And one type of monotonic correlation would be a linear correlation. And that is the type of relationship where you see where the values on one variable, let's say the values on the independent variable and the values on the dependent variable, in each observation, they line up to make a line like you would see on a line graph. Okay, on the next slide, I'll show you guys some examples so that you'll be able to have more of a clear picture of what I'm trying to explain to you. So a positive correlation, it means that as one value goes up, the other value goes up. If you look at the top, in the top A, you see as the high goes higher, on the left, on the bottom axis, you see that that also goes higher. And then with the negative one, the relationship looks inverse. On the vertical axis, as it increases, the horizontal axis is decreasing. So that's why we say a positive versus a negative correlation. Are they moving in the same direction, or are they moving in opposite directions? And this is considered to be a just a negative monotonic correlation instead of being a linear one, because if you look at the bottom, we see that this relationship is the same in C and D, but those points come together to form a perfect line or close to a perfect line. If they don't form a perfect line, then it's not considered to be a linear relationship. Instead, it's considered to be a monotonic relationship. So now we know what those correlations look like when they are graphed, and we also have a good idea of the definitions for those things. Let's talk about looking at them in a table format and being able to have some sort of understanding of the relationship between values when it comes to tabling them. And we table them using categorical data, using cross tabulations or contingency table. So cross tabulation is going to show the joint or bivariate relationship between two categories. That means that if you have, as I said earlier, gender and party ID, then you're going to have those two variables. Remember, it looks at bivariate relationships, meaning two variables. So you take and you are making a table for two variables and seeing how those two variables work together and the relationship that unfolds there. And it allows you to investigate an idea, an assertion that you had from the hypothesis. And then you're able to draw conclusions from that as far as the association between those two variables that you're interested in. We use those tables to summarize the information that we have in our data matrix or our data set. So you have your data set, and this is a lot of great things, but the table can kind of give you a better summary of what you see existing. So here's an example of a cross tabulation table, and they're interested in understanding the relationship between partisanship and donating money. Now, if donating money was a numeric value, then this wouldn't be appropriate because it's appropriate when you have categorical data. But instead of having like the amount of money in dollars, they're just reporting whether somebody donated or didn't donate. And that is considered to be a label or a category. So we can use this type of measure, cross tabulation, to answer that question. So we have donate, did not donate, that's our dependent variable. And then we have our strength of the party ID. So this isn't looking at whether or not they are Republican or Democrat, but it's looking more so at whether or not they identify with one of the parties. If they don't identify with the party, then they're put in the independent category. So if they feel like they have weak identification with a party, they have a category of moderate identification and strong identification. And we're trying to see how that strength of that identification relates to whether or not they choose to donate money. So if we look at this chart and we go down and we'll look and we'll see when it comes to donating money, people who have a strong party identification, about 32% of those people reported donating, and that's about 103 people, which is high. But when we go and we look down at the weak side of things, we look of the people who did not donate, we see that those who have a weak identification also reported not donating. So progressively, we can see that as we go down the first line that says not donate, the amount of people who did not donate decreases under the no column as the party ID gets stronger. Looking at the yes column, we can see that those who have a party ID, a strong association, donated the highest, and we see that weak donated the lowest and moderate donated in the middle. So we see that the stronger the party identification label is for that individual or this group of individuals, the more we see reporting donating. So we see here that, as we talked about earlier, about that correlation, that association between two variables, the association that we see here is that as the party identification is stronger, the more likely a person is to donate. They donate at greater rates. Those with higher party identification donate at greater rates, and those with lower party identification donate at lower rates. So this sounds like what we were talking about a few minutes ago as far as the association, as far as the correlation between the two things. Now, looking at this cross tabulation table, it shows us that there's an association between these two variables, but it doesn't tell us how strong that association is. And in order to be able to determine how strong the association is, we have to look at some additional measures. And let's take a look at those. So we have to start looking at the strength of the association. And it's something that is pretty intuitive, so we can get through it pretty easily. We need to be able to measure the strength of an association, and the strength of an association is measured on a scale of -1 to 1. So I'm going to tell you about what the strength of that relationship means in the table that's on the right, but I'm only using the absolute values within this specific table. You can have an association, a relationship where it is -1, but that doesn't mean it's any less strong than 1. As long as the association is like a perfect 1, that means that there's a perfect relationship between the two. A measure of 1 means that there is a perfect relationship between the two. A measure of 0 means that there is no relationship between the two. This is something that is usually calculated in software, but you can also calculate it by hand. This is where we're able to detail as one thing moves in time and the other thing moves in time, are they traveling at the same speeds? So for instance, we'll think about the example of the freeway. If you are on the freeway and you and another car are headed towards the same thing at the exact same speed of 70 miles per hour, then you guys have a perfect relationship. You are riding side by side down the freeway, traveling the same speed, going in the same direction. But if you all are going in different directions, one is going northbound, the other one is going southbound, but you're still traveling at 70 miles per hour, and you're going at the same pace all the way there, then you would still have a perfect relationship. It would just be inverse. So that would be a relationship of -1 because you're traveling in opposite directions. But if you have a car, one is going 70, the other one is going no miles per hour at all, is stuck side the road, then they aren't moving together in time. So their relationship with each other is going to be 0. Because they are not moving in the same direction and they're not moving at the same speed. So they don't have a relationship with each other. This measure, as far as strength of relationships is concerned, tells us this thing. Do we have two things that are moving at the same pace going side by side? Two things that are going in the opposite direction of each other but moving at the same pace? Or two things that are completely going in different directions, different paces and everything? And we're able to tell with these numeric values what that relationship looks like. So thinking back to my example that I gave a minute ago, the value part tells you how close in speed these two things are traveling. So 70, both cars going 70 and 70 would be considered to be a 1, which is a strong, perfect relationship. But let's say two cars, they're riding down the road headed in the same direction, but one's going 70, the other one's going 65. That's not a perfect relationship, but we do know that there's a relationship that exists between them. What this table tells you is that even if they're not traveling at the same speed, there is a point of correlation between them, a point of relationship between them and what that rate is. So if they're not traveling at the same speed, they could have a weak relationship, they could have a moderate relationship, or a strong, close to perfect relationship. 0.3 or below, these are just rules of thumb to help you remember this. If you see a strength of relationship test, it means that there's a weak relationship between the two. They are not necessarily traveling at the same pace or in the same direction. So these are all absolute values. It could be -0.3. It's just, absolute values just to make it easier. 0.4 to 0.7, that is a moderate relationship between two variables. Again, not traveling at the same speed, but kind of getting closer there. And 0.8 or above, that's when we're traveling at the same speed, and that is a strong relationship, with 1 being the perfect indicator of a relationship. So this indicator, the strength of the relationship marker that we use, tells us At what rate are these things traveling alongside each other? Our two variables of interest. So just keep that in mind, because it's kind of like an easy way to interpret it when you read it in a table or output. Now, we've been able to establish that a relationship and association exists. We've been able to establish the strength of that relationship. Now we need to talk more in detail about the direction of that relationship, which we kind of hinted at a little while ago. But the direction of a relationship shows how the values of the independent variable are associated with the values of the dependent variable. The direction of the relationship tells you whether or not they're traveling within the same direction or if they're traveling within different directions. This is something that can be visible in contingency tables, and I'll show you all an example of that, where you can figure out the direction of a relationship by looking in the contingency table. But it's something that is very clearly explained and visible using statistical software, because statistical software can graph the relationship between two variables, and it can also give you a specific number to tell you the direction of the relationship between the two. But a shorthand way of knowing the direction of the relationship between the two when you're talking about software is whether or not the number is positive or negative. If the number that you get, like that the computer spits out for the direction of the relationship, if it is a negative number, then you know that that is a negative relationship, meaning that as one variable increases, the other one decreases. But if it is a positive number, then you know that that relationship is where as one variable increases, the other variable increases as well. So let's look at our table and see if we can interpret the direction of a relationship here. So if we look here at this table, we are looking at years of education and interest in campaigns. And let's see if we can figure out the direction of the relationship looking here at this table. So high interest in campaigns. We see that the group that has the highest interest in the high group is the group that has more than 13 years of education, 13 years or more. Now let's look and see who has the lowest interest in campaigns. And we see that the lowest interest in campaigns out of that row would be 28.7%, and that goes to the group that has 11 years or less of education. And if we look at the moderate column, who has the most interest in the moderate level, we see that those around 12 years of education have a moderate interest in campaigns. So looking at this table, we're able to determine that high interest in campaigns is highest among those with the highest education group. Moderate interest in campaigns is the highest amongst those with the moderate education group. And low interest in campaigns is highest amongst those with the lowest education. So we're seeing here that high interest is associated with high education. Moderate interest is associated with moderate education. Low interest is associated with low education. So what does this tell us about the direction of the relationship? It tells us that it has to be a positive relationship, because as the years of education go up, the interest in campaigns goes up as well. So that's one way to look at a chart and to be able to tell whether or not, to be able to tell the direction of the relationship. This chart would tell us the direction of the relationship, but it doesn't tell us the strength of the relationship. So we're back to having a piece of the puzzle instead of the whole puzzle. And because we don't have the whole puzzle here, that's why we use statistical packages to give us more complicated, in-depth understanding of the data. Having a chart like this is great, and it provides us with great information. But we would get a wealth of information by using computer software. So we can use this chart to interpret the direction of a relationship. But if you want to get the strength of the relationship, the direction of the relationship, the level of association, and all of these things at one time, Social scientists use statistical packages so that they'll be able to get this information in addition to those charts. And they're able to graph points so that we can see if it's a perfect linear relationship, is it a positive monotonic relationship or a negative monotonic relationship, and we get all of this at once. But these are just some examples that your book outlines for ways of determining this if you don't have access to statistical packages. But I want to take a minute and stop here pretty much because I don't want to overwhelm you with information. This section we just touched upon strength of relationship, we touched upon the direction of the relationship and being able to identify associations. We're specifically looking at categorical data, meaning variables that are either nominal or ordinal variables here, and the procedures or methods you would use to analyze that sort of data. So for your project, you are interested in using categorical, two variables that consist of categorical data. This is where you would start in your analysis of those two variables. We'll talk further in chapter 14 about analyzing data that doesn't fall into the category of categorical data. But these are the methods that you would use in order to be able to interpret your data specifically. Earlier, I showed you how to be able to tell the story using descriptive statistics, which would be the individual variable. Here, within this chapter, we're talking about how to tell the story using two variables. And that is where we have bivariate analysis, and we start talking about association, strength of relationships, and correlation. So I'll go ahead and I will stop here. And then we'll pick up next time talking about measuring association in chapter 13.